morning, students. So today's class we are going to see about the analysis of recursive algorithm. So last video we discussed about the three notations, asymptotic notations, big O, big omega, and big theta. Now we are going to see about recursive algorithm. So first, the basic parameter for recursive algorithm is to decide on the input size of the algorithm. The second most important step is to identify the algorithm's basics operation. So what are the basic operation? You have to analyze the algorithm basics operation. And third one is you have to find out the number of times it has been executed, because inputs will be given from the same size or different size. You are going to analyze the inputs. Okay, after analyzing the inputs, you are going to set up a recurrence relation, and from that recurrence relation is to get some value, and that value will express the number of times the condition which is being executed. And then finally you have to solve the recurrence. Okay, recurrence by using backward substitution method or backtracking. So these are the 5 important steps in analysis of the recursive algorithm. So now next we are going to see about a small example for this. So now you can see in this is a small example for recursive evaluation. So this algorithm is f of n equal to f of n minus 1 into n. So for n greater than equal to 1. So from the definition you can see, if you substitute 1 in this, so if you substitute here 1, so here it will be 1 minus 1, it will become 0 here. Okay, so and then next greater than equal to 1. Okay, so then if you substitute 2, so 2 minus 1 will be 1, and 3 minus 1, so it goes on. So starting from 0, 1 and 2 it goes on. Okay, so the output for this is 0, 1, 2, it goes on. Okay, so from starting from the value f of 0 equal to 1. So in this recursive evaluation of this algorithm, first you have to compute n factorial. Okay, you have to compute the n factorial, that is n factorial is n into n minus 1. So that is this is a small example for calculating the factorial. Okay, so the input which is given here is non-negative integer, and the output is you have to find the value of n factorial. Okay, and also you can use this n multiplication shown as m of n equal to m of n minus 1 plus 1. So this is a small example, and by this relation you can see the value of m of n is given to you. So m of n equal to m of n minus 1 plus 1. So first parameter you have to substitute the n value here. Okay, if you substitute the n value as 0, it becomes minus 2 plus 2 will be 0. So whenever you substitute the 0, the output will be 0. So when now if you give the based upon the values of n, so 0, 1, 2, the values will be changed here. So this method we call it as backward substitution. Backward substitution, you have to subtract with the ith value. Okay, so from the n value you have to subtract with the I value, and then you have to add with the value of I. So this is the formula for backward substitution. So remember students, for backward substitution what you have to do is you have to subtract the n value with the I value, and you have to increment it with the value of I. So this method is called as backward substitution method. Remember, in a recurrence of this important concept, so the main example is in this factorial example, this backward substitution is important. So already we have seen from this given slide. So first you have to check the basic operation. So the basic operation of the algorithm, and in this algorithm you have to set up a recurrence relation. So what is the recurrence relation here? M of n equal to m of n minus 1 plus 1. So by this we can you are going to set a recurrence relation, and after setting the recurrence relation you are going to solve the recurrence relation. So how do you solve the recurrence relation? You have to solve the recurrence relation by the method of backward substitution. So by this method of backward substitution you are going to solve these kind of problems. So this is the best example. This factorial is best example for recurrence relation. So another example, Tower of Hanoi, we will continue this in upcoming video. So any doubts you can post it in comments.